everyone, this is Mansi Bora, and today I'll be demonstrating about a topic named delivering superior customer experience with NGINX and App Protect Insights. So imagine that you're managing a critical online service and customers are flocking to your website. Every day our servers are inundated with requests from users and bots alike. So while some requests are legitimate, others might pose a threat. And without having a clear view of what's happening, spotting issues like security threats or performance bottlenecks can be like searching for a needle in a haystack. So, what is the solution for this? The Web Application Firewall, your web servers, and your load balancer generates vast amount of logs, which captures everything from the potential security threats to your user interactions. So while these logs are very crucial for understanding that what's happening, raw log data is overwhelming and difficult to interpret. You might find yourself drowning in lines of text, trying to identify patterns or issues that could impact your website's security or performance. And this is where Kibana comes in. So Kibana is a powerful tool that turns your complex log data into clear interactive visualizations. And it also provides you real-time monitoring. And by visualizing these logs, you can easily spot trends, detect anomalies, and even forecast the patterns to understand the overall health of your web applications. Because Kibana will transform the log data into actionable insights. So your time to identify, rectify, and respond to a problem improves. I'll quickly walk you through the architecture that we have built up. So we have the end user that will initiate the request, such as accessing a website or the application. And all these requests will first reach to the load balancer. The load balancer will decide that which web server should handle which particular request. So it will basically distribute the request among the web servers. Next, we have the reverse proxy. So the reverse proxy will handle the communication between the user's request and the web servers. So it will act as an intermediary. So it will mask the web server's identity basically. Next, we have the Web Application Firewall. So the WAF inspects the request for any security threats. It will filter out the malicious traffic to protect our web servers. The web servers will process the requests that come to it and will generate the response for it. So all these logs from the load balancer, from the WAF, and from the web servers are pushed to Logstash. So all these logs are basically distributed into different fields. So a single log line will be divided into different fields, and for this purpose we have built grok patterns on Logstash. So it becomes easier for us to read through our logs, and we'll have proper different fields of our logs. And all these different fields and all this data will be pushed to Elasticsearch. So this is an Elastic cluster in which we have Elasticsearch, we have Logstash, and we have Kibana. Now that data is on Elasticsearch, the data will be easily searchable and analyzable. The data is being pushed to Kibana further, which will be your browser UI. So Kibana will be used for visualizing the data that is stored in Elasticsearch and will allow the users and administrators to monitor, analyze the system's performance and security. So we have built dashboards for infrastructure, WAF, web servers, and load balancer. Infrastructure monitoring is all the metrics of your load balancers, of your WAF, and your web server. So we'll go to the first dashboard, which is infrastructure monitoring. So this particular dashboard will give you all the metrics for web servers, for load balancer on one single dashboard. So we have consolidated the metrics of all the servers into one dashboard. So you can check the CPU usage, the memory usage, the load balancer, the inbound traffic. So all of these metrics I have consolidated here. What is the system load? Everything is present. But since today's topic, we're mostly focusing more on the logs that are coming, we'll quickly jump to our WAF dashboard. So WAF is basically used for detecting all the security threats that are coming to your website. So it will capture the data related to the potential threats such as attacks, blocked requests. It will identify and mitigate the risks like SQL injections, cross-site scriptings. So all of these things are captured by WAF. So the first visualization that I've created is for the top URLs. So it will tell you that which URLs are being accessed most frequently. It will help you identify the URLs that are receiving disproportionately high number of requests. So let's take an example of the first one. So you can literally check here that which URLs are having the most number of records on it. So say 342 records. So 342 people have tried to access this particular URL. So it might be a case that there might be some kind of an attack being made on it, like say brute force. So brute force attack is basically when an attacker tries to attempt or guess some kind of passwords or encryption keys or other security information by trying a large number of possibilities, which then eventually creates a lot of requests. So all these possibilities can be seen here and checked from here. And then further, you can easily go to your logs on Kibana itself. I'll show you that as well, that how easily can you go through the logs and you don't have to log into your servers at all. The second visualization that I've created is for the top talkers. And by top talkers, I mean the top client IPs that are making the most requests. So it will help you identify the malicious IPs. So high activities from a single IP or few IP addresses could indicate that there is some malicious behavior being done, like some DDoS attack or other attack. You can also take the IP blocking decisions from this visualization. Like you can make informed decisions about blocking some IPs or throttling the traffic from certain IPs. Next, we have the request distribution. So this is the distribution of different requests like blocked, like alert. So blocked requests are the requests that are blocked by WAF. And this happens when some request is malicious or suspicious based on the predefined rules or the policies and signatures that we have created in the WAF. Alerted requests are the requests that are triggered with an alert, but they are not blocked necessarily for potential threats, but you may investigate them further. So here I've created the request rate for these blocked and alerted requests. So you can understand and identify how these patterns are throughout the time range. So you can easily change your time ranges and jump into whichever time you want to check all these things for. Next is the responses distribution. So responses distribution is the breakdown of all the HTTP response codes that are coming to your website. So through this, you can understand the overall security and health of your web application. See, now you can see that there are 369 requests having zero response code, which means no response. So this might be due to some kind of network error or some incomplete activity being done on your web application. So you can just go to your logs and check what is being done. So there are different types of HTTP response codes, like 200 series will be for successful response codes, 300 series is for redirection responses, 400 series is for client-side errors, and 500 series is for server-side errors. So if you see a lot of 400 or 500 series being seen here, so it might mean that there is some kind of error or some kind of activity being done and which needs immediate attention. And you can also check the pattern for each of these status codes. Next is signature. And before jumping into these visualization of signature, violations, attack types, I'll quickly give you an idea about what these actually mean. So for detecting the attacks or suspicious activities that are coming to your website, we have violations. So violation will basically detect all these attacks. And after that, we are creating rules, policies, or solutions to avoid these attacks. So signatures are basically used for protection purposes. So each of these attacks will have a particular signature being assigned to it. So as you can see here, we have around 36 records with this particular signature and which stands up for cross-site scripting. So if someone is trying to scrape your website, so you can easily understand all those activities and signatures will detect them. You can also check for the patterns as per your data. Now we have the violations distribution. So these are the type of violations that are detected by OWAF. It will identify the potential security threats that are coming and help you detect the areas which require more protection and tuning. So, for example, let's take that bot client detected. There were 54 requests with this. So, this means that this traffic is originating from some kind of bots or automated scripts for scraping the data or attempting attacks in your website. And you can also check for the patterns of how these particular violations are working, how some client IP is trying to access your websites. So all these trends can be seen here easily, which you don't find easily through the log lines. Now we have violation ratings. So these are basically a distribution of violations based on the severities. So 5 is for the highest severity and 1 is for the lowest severity. So if you see a lot of number of 5 ratings here, you can easily go and check into your logs what is being done. Why is it giving a rating of 5? Next is the attack types. So in this, you can check that which kind of attacks are coming on your website. It will detect the exploitations, the vulnerabilities in your system and application. So if there are some attempts that are for gaining the authorized access or disrupting the normal operations, so those can be detected from the attack types visualization. So now if we see forceful browsing, so there are 63 requests. So forceful browsing is basically gaining the access of some restricted parts of an application by manipulating your URLs or some kind of parameters to bypass the authentication or authorized checks. Next is abuser functionality. So abuser functionality can be like exploitation of some legitimate functionalities in ways in which the developer has not meant to do that. Like your developer has not allowed that, but someone has tried to abuse that. Non-browser clients could mean that there are some non-standard clients or tools which are trying to interact with your website. And all these activities and trends for each can be identified through this particular visualization. So this is a time series for all your attack types. Now, this geomap will help you know that where all the legitimate activities or malicious attacks are taking place from. So this plays a very crucial role. So if a majority of attacks are coming from a specific region, you might adjust your security policies to mitigate the risks associated with that particular traffic from those areas. So you can literally do the throttling of those traffic. You can check in the logs and you can stop those, attacks from happening. Now these are the tables which you can adjust and manipulate as per your conditions. So now we want to check that in every 3 hours, which type of methods are coming and how many records are there for each of the method. The time can obviously be changed as per your requirement. So say there are 36 records that have come up for GET request and 27 requests for POST request. Similarly, in every 3 hours, you can check those particular requests that are coming for each of the methods. Now we have a chart for the violations for activities. So it will tell you the violations, it is made by which client IP, what was the attack that was being done, what was the method, what was the request status that your WAF gave it, was it blocked, was it alerted, what was the response code, was it like, did your web application give it a successful response, a no response, and how many records were there for each of them. So all these activities you can easily get from this and you can change these conditions as per your requirements. Now the next dashboard that we have is for our web server logs. So this dashboard will help you understand all the logs that are coming to your two web servers. Now if you see that these two visualizations will help you understand that whether the load balancer is distributing the load amongst the two web servers almost equally or not. So you can understand the health of your load balancer through these two visualizations. It won't be exactly equal, but it will almost be equal. And in our case, we have used the round robin method for distributing the load amongst the two web servers through load balancer. But there are different methods like weighted round robin or IP hash, hashing, etc. The next visualization that I've created is again for the status code. So you can see that there are a lot of 200 status code, which means successful responses. So which is a good sign for you. But if you see a lot of 400 or 500 status codes, then it is It is something that you need to check in your logs. Now, this is an anomaly detection visualization that I've created, which we'll come back to it in some time. Again, this visualization is for the top URLs. So you can detect that which URLs are being hit by your client IPs the most. Again, what is the number of status codes? Like what are the count of records for each of the status codes? What is the time series pattern for them? So all these activities and trends can be checked and monitored from this visualization. Again, the methods, for all the methods, what is the number of records for each of the method? So if you see a lot of delete methods or put methods in a more number of proportion, then it signifies that there's something wrong or some activity being performed on your website. And all the trends can again be monitored from this particular visualization. The top talkers is again for the client IPs, the top client IPs that are interacting with your web application. And how is the pattern for each of the client IPs can be detected from here. So if you see that at a particular time of the day, every day, some client IP is trying to access your website a lot. So you can just go to your logs and check for all the activities that this particular client IP is performing. I'll also show you how you can check the logs on Discover on Kibana. Now, this is a very interesting heat map that I've created for understanding the correlation between our client IPs and the response ports. So for every client IP, you can check that which response ports are present. So for this particular client IP, you have 17,938 records for 200 status code, which is for successful status codes. 404 is for the client side error. So there are 74 such records with a 404 status code for this particular client IP. So this heat map will help you understand that how your client IP is trying to interact with your web application and which particular responses are present for each of them. This is a very interesting table that I've created to understand that for a client IP, what is the request that it is making? What was the status code that was given to it? The request keyword that it gave? And how many such records are there for each of these client IPs? So you can always change these conditions as per your requirement, and you'll have all the number of records as per these conditions present. Now let's come to a load balancer visualization. Again, this particular visualization for the methods will help you understand the types of methods that are present on your web application. So again, if you see a lot of delete or a lot of put methods being present, that signifies that you need to check what is happening, what those logs are identifying. And you can check the trends for each of these methods. Now, log levels. So log levels are basically the severity of messages. So errors will tell you that there is some significant problem that has caused some function component to fail and which has caused error in that particular request. Now, if you want to check the logs for these errors, you can easily go to Discover our load balancer LB index. So we'll select the LB index and we'll search for the keyword error. And you'll easily get to see all the requests that have error as a keyword in them. So it is that easy for you to go and check in your logs, and you don't have to go to your server and try to log in into it, go through the logs. All these logs are readily available for you, and all the fields are also distributed. So for each of these logs, all the distributed fields are present. So this has been done using the proc pattern. So you can also check for the pattern of these logs. So what was the pattern of the error logs? What was the pattern for the warn logs? Warn basically indicates that something unexpected happened or it might be a potential problem and should be monitored. Next, we have the top client IPs, which are trying to interact with your web server. The status codes again. This is a heat map for your methods and your status codes. So for each of the method, you can check that which status codes are being hit. Now for your get request, for your get method, there are 4,13,000 486 requests in the last 30 days with a 200. That is successful response. For 301, there are 30,039 requests. So all these numbers can be easily being fetched here, and you can just go to your logs and check for the activities. Now we have byte sent. Byte sent will tell you that what are the number of bytes that are being sent out of your web application. You can check for the trends, and if you see that a lot of data is going out of your web application, you can easily check for the activities. So it will help you identify that how is the health of your web application. If it is in thread, the bytes will be sent more. Now this is a table for the top messages that are error messages that are there in your web application in the requests. So there are 263 records with this particular error message. So this error can be monitored from this table. This is again a heat map for your client IPs and the log levels. Like for a particular client IP, which were the log levels, errors and ones, and what was the number of records for each of them. So I hope this particular visualization was clear for you. Now, we'll go to the visualization that we had talked about, that I had told you that I'll come back, is the anomaly detection. So the first anomaly detection model that I've created is for the request.keyword field. I'll show you the data that is present in it. So as you can see that it is a combination of the method, the resource, that is the path requested, and HTTP version. So all these requests that have come are unique, and this signifies the cardinality. So the y-axis has the cardinality of all the requests that have come in. So the unique request.keyword values. So all these values are unique from each other, and these signifies the cardinality. The time frame that I've set is 15 minutes. So the bucket of 15 minutes, it will tell you that how many requests have come up, like how many unique requests have come up in the 15-minute time frame. So if in a usual pattern, there are suppose say 40 unique values of requests per time bucket, and suddenly if you see it going to 80, or if it is going to one unique value, so this particular deviation in the number of unique values, is what gets flagged as an anomaly. And every anomaly is given a score from 0 to 100. So it is from 0 to 24, it is a warning. If it is from 25 to 49, it's minor. If it is from 50 to 74, it's a major anomaly. And if it is 75 or beyond, it is a critical anomaly. So as you can see here that this has been flagged as a critical anomaly. The anomaly score is 94. So the actual value right now is 348. This was on 18th of August. Now let's go to 18th of August. Let's look into the anomaly that has come up. So the ideal value should have been 3.4, like around 3 unique values. Because if you see here, there are a lot of small values that are there. 6 is there, 1 is there, 9 is there. So it should have been here, but it has directly gone up to 348. That is why it has been given an anomaly score of 94. So this particular deviation in your cardinality is an anomaly. So now let us take another example of, say, suppose this. On 14th of August, the actual score right now, the actual value right now is 323. Whereas it should have been around 2. So if you see here, there are a lot of small values that are present, but it is deviated directly from these values like 1, 2, 3 to 323. And that is why it has been given an anomaly score of 78. So all the multiple dimensions can be studied by your anomaly detection model. And the more the historical data you have, the better the model reads. So you can understand that what is the potential cause if there is some unusual traffic pattern, if there are some spikes in the cardinality. So that will indicate that there is some unusual or abnormal traffic behavior. So the sudden influx in your traffic from diverse IPs or different IPs could cause the observed cardinality to increase sharply. So, which means that there's some attack like DDoS attack or brute force attacks. So, all of these attacks, all these deviations and anomalies can help you detect them. So, by examining these anomalies, you can investigate whether these are expected deviation due to some legitimate changes, like if you have some new marketing campaign or some kind of an offer or some system update on your website or web application, then that is an expected result, right? Then the spikes are expected. But in the other case, if you don't have any such activities being performed right now, so that could indicate that there are some potential issues that need to be addressed. Next, I have another anomaly detection, which I have created. The input that I've given is the request keyword and the client IPs. And I have given the output for different status code. So say for 200 status code, you want to check which were the anomalies as per the request keyword and which client IPs were causing those. So that can be checked. So say for example, on 22nd of August, 22nd of August, there was an anomaly. Okay, so the actual value should have been one around 1, 2, but there are 23 unique values at that particular time. So from here, it is directly being deviated to this. So there is a lot of uniqueness in your request. And you can check from here that which client IPs have performed these, anomalies to come here. So it is that easy for you to detect all the anomalies, provide different kinds of fields to your anomaly detection models, and understand your data thoroughly. So this is the power of Kibana and the anomaly detection models. So I hope that this overview and demonstration gave you a clear understanding of how dashboard and logs can help you integrate and maintain a robust and resilient infrastructure to maintain the peak performance of your applications and websites. Thank you so much.